Section 1.5, we start working with fractions. And there's some skills with fractions that we'll learn. We'll learn how to multiply fractions, reduce fractions, divide fractions, and add and subtract fractions. Let me just kind of jump into this section. This section starts off talking about equivalent fractions and how to create equivalent fractions. And it essentially says, if I take a fraction, say 3/4, and if I multiply that fraction by 1, I'll create an equivalent fraction. If I really just multiply a fraction by 1, anything times 1 is itself. These are they're actually exactly the same fraction. If I multiply by 1 but take a more clever form of 1, then I'm going to create a fraction that is equivalent, which means it would have the same decimal equality, but it'll look different. So multiplying by 1 doesn't change the value when you multiply any number by 1. So if I multiply 3/4 by 1, but in this case by 5/5, I just picked 5/5 randomly because it was a number I can work with in my head. This fraction is equivalent to that fraction. These fractions are equal or equivalent to each other. So the equivalent fraction property just basically says if you multiply the numerator and the denominator of a fraction by the same non-zero number, the resulting fraction is equivalent. So that these two fractions, 3/4 and 15/20, are equivalent fractions. Super useful skill to be able to rewrite fractions into equivalent fractions when we're adding and subtracting fractions. And in this section, let me just get into this section real quickly, and then we'll talk about when that skill is going to be important. So each of the problems between 1 and 8 give us a fraction, and they want us to write an equivalent fraction that has a 24 in the denominator. So I'm going to use this equivalent fraction property, and I'm going to multiply the fractions that are given in problems 1 through 8 by some fraction that's equal to 1 to create a fraction that's equivalent to the original fraction yet has a 24 in the denominator. If it's not obvious how to make 5/6 into a fraction that has 24 in the denominator, what I'm going to do is I'm going to multiply by a fraction that's equivalent to 1. And to figure out what to multiply by, I'm going to divide the desired denominator by the given denominator. I want to rewrite this fraction with a denominator of 24, so my desired denominator is 24. This fraction has a given denominator of 6. 24 divided by 6 is 4. I claim that if I multiply this fraction by 4/4, which is just multiplying by a different version of 1, I'm going to create the equivalent fraction that has the desired denominator. I'm just going to multiply across the numerator of the fraction. 5 times 4 is 20. And I'm going to multiply across the denominator of the fraction. 6 times 4 is 24. That's going to be the answer to problem 2. The fraction 20/24 is equivalent to the fraction 5/6, just has the new denominator that's desired. For problem 4, I want to take the fraction 11/8 and create a fraction that's equivalent to it that has a 24 in the denominator. And to figure out what to multiply by, my desired denominator is 24, my given denominator is 8, and 24 divided by 8 is 3. So I'm going to take the fraction 11/8, multiply it by 3/3, which is really just multiplying it by 1. Do 11 times 3 across the numerators and get 33. and 8 times 3 and 24 in the denominator. The two fractions 11 over 8 and 33 over 24 are equivalent fractions. Few more. 6 is a little bit tricky because 6 gives me something that's not a fraction and it wants me to write an equivalent fraction with a 24 in the denominator. In order to deal with 6, I need to take the 4 and write it in its fraction form. Any integer can be written as a fraction if you just write it over 1. And now my desired denominator is 24. My given denominator is 1. So to figure out what to multiply by, to get my fraction with the desired denominator of 24, I want to change my denominator to 24. I have a denominator of 1. I form a fraction that has an equal numerator and denominator, and then I multiply. 4 times 24 is 96. 1 times 24 is 24. So the fraction 96 over 24, it will reduce to 4 over 1, or just 4. Last one of these problems, I don't do a lot with mixed numbers, but we'll do a little. In order to make a fraction that has a 24 in the denominator, I have two choices for a mixed fraction. I could just leave the coefficient, or I don't know if it's really called a coefficient, but I can just leave the 7 part and just work on the fraction 2/3. So I can leave it as a mixed fraction. Which is completely fine. It's not what I would instinctively do, but there's nothing wrong with doing this strategy. Creating a new fraction that has a denominator of 24 that's equal to the original problem. So again, what to multiply by? My desired denominator is 24. My given denominator is 3. 24 divided by 3 is 8. If I take the fraction part of 7 and 2/3, ignoring the 7 part, and multiply it by 8 over 8, I'm going to get this mixed fraction. 7 first, and then 2 times 8 is 16, and 3 times 8 is 24. This would be a correct answer for problem 8. And when I look at my answers, this isn't even the way that I thought. It is a way that I thought to do it, I guess. It's not just the natural way that I would do it. The alternative would be to make this mixed fraction into an improper fraction. So the alternative is to create an improper fraction. An improper fraction has a bigger numerator than denominator. To do that, I'm going to multiply the 3 times the 7 and add 2. Create a fraction that has the same denominator with a new numerator. So the improper fraction version of this would be 23 over 3 again. It's just 3 times 7 plus 2. And this is a fraction that has a 3 in the denominator. If I want to create a fraction that has a 24 in the denominator, I do the same process. I want to have a 24, but I have a 3. I need to multiply by 8 over 8. And then all of a sudden, this is really calculator worthy to do 23 times 8. I can do it in my head, but I don't have to. When numbers get big, I kind of expect most of you to just pull out your calculators. I'll keep the numbers small on the first test so that you don't need a crutch of a calculator. But for the rest of the semester, once we get past the first test, calculators will be completely permissible. So that's good for 8. And now we're going to get into the next section, which has to do with simplifying fractions. And there's a couple ways to simplify fractions. What I'm going to do is, not what I expect you to do if you already know how to reduce fractions. If I give you a fraction and you know how to reduce it already, then you don't have to go through the process that I'm going to go through. I usually reduce fractions kind of in my head, but in my head is kind of a dangerous way to reduce a fraction. So what I'm going to do is for each of the next problems, 9 through 16, I'm going to reduce the fraction. If you look at problem 10 and you know how to reduce that fraction already, then there isn't any special skill that you need. You already know how to do what you need to do. If you don't, I'm going to rewrite the numerator and the denominator to show what I'm going to cancel out. And in order to do this strategy, if you have no idea how to reduce fractions, I'm going to pull out some factors of the numbers. So I'm going to look at the factors of 24, the integers that multiply to 24. This sheet's provided as you open up the section, so this is something you have access to for the test. So I'm going to look at the factors of 24. On my little sheet it says 24 is 1 times 24, 24 is 2 times 12, 24 is 3 times 8, and 24 is 4 times 6. I'm going to move over to the denominator and find all its factors. 56 is 1 times 56, 2 times 28, 4 times 14, and 7 times 8. So 56 is, the work's already done for me, so 1 times 56, 2 times 28, 4 times 14, and 7 times 8. Between the factors, I look for the biggest common factor. So I look at all the factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Similarly, I look at all the factors of 56. And I notice that there's a couple numbers in common. 2, 4, and 8 are factors that they have in common. 8 is the largest common factor. What I'm going to do is I'm going to rewrite the fraction with the 24 written as 3 times 8 and the 56 written as 7 times 8. The reason I'm picking these pair of factors is that the 8 is the largest number of the factors that they have in common. Now I'm kind of doing the reverse of the equivalent fraction property. I'm creating an equivalent fraction by essentially going backwards. Instead of multiplying by a fraction that's equivalent to 1, I'm kind of dividing by a fraction that's equivalent to 1. I claim that this fraction, 3 over 7, is the reduced form of the fraction 24 over 56. That's way overkill. So if you were just able to reduce the fraction by looking at it, then doing this extra work isn't necessary. And eventually I'll stop doing this extra work, but not so much in the first section, for the first 10 problems or so that we're going to do. So problem 12 wants to reduce 40 over 44. So you have access to this sheet. I'm going to write down the factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. So 40 is 1 times 40. It's 2 times 10. I'm sorry, it's 2 times 20. Duh. It's 4 times 10. And 5 times 8. 44 is 1 times 44, 2 times 22, and 4 times 11. And similarly, I look at my factors and find the largest common factor, which is the 4. So now I'm going to rewrite this problem. I'm going to take the 40 over 44. The order doesn't matter, but I guess I'll make the number that cancels written second for a bit, and then I'll probably forget that I suggested that. So I can write 40 is 10 times 4, 44 is 11 times 4, and now I can cancel the 4's. And I'm going to create the equivalent fraction. The fraction 10 over 11 is equivalent to the fraction 40 over 44. Again, this is overkill if you already know how to reduce fractions without going through this formalized process of writing out the factored form and canceling the common factor. it's better to do it in your head. So if you just went from here to here and you said 40 divided by 4 is 10, 44 divided by 4 is 11, and you just wrote a 10 over 11 down without showing any work, that's better. But not everyone can do that, so I want to make sure everybody can get this done when we're in the non-calculator mode. So 14, I want to reduce the fraction 12 over 38, and the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. The factors of 38 are 1 and 38, and 2 and 19. If there weren't any common factors other than 1, this would be reduced. But there is a common factor. The largest common factor is 2. So I'm going to rewrite this problem. 12 over 38. The 12, I'm going to say, is equal to 6 times 2. I already might not be consistent with how I'm setting this up. It doesn't matter when you rewrite this, how you write the factors, as long as there's a common factor between the numerator and the denominator, they're going to cancel if they're written on top of each other or not. So I rewrote the 12 and the 38, set it up to cancel the 2. The answer to problem 14 is going to be 6 over 19. For 16, for such a small factor, I didn't put it on this list, assuming I could know the factors of 4 without having a list. The factors of 4 are 1 and 4, and 2 and 2. Then I'll move over to 60. 60 is a ridiculous amount of factors. So for 60, it's 1 and 60, 2 and 30, 3 and 20, 4 and 15. Rather than writing all these down, I'm just going to write the one that I need. The 4 and 15 factor of 60 is the best one to use for reducing because it will match up with the largest factor of 4. So now I'm going to rewrite both of these. I'm going to write the 4 as 1 times 4. I don't really need the 1, but it's kind of nice to have it there. And I'm going to write the 60 as 15 times 4. Now I'm going to cancel out the 4's. And the equivalent fraction I'm going to get is 1 over 15. If I didn't write the 1 preceding the 4, then I might have not known to put a 1 in the numerator. Anytime if you don't write the 1 and you cancel the entire numerator, you need to leave a 1 behind. All right, new skill. This skill is going to set us up for when we're dividing fractions. This skill just asks me to find the reciprocal of a fraction and leave your answer as an improper fraction. Don't make mixed fractions. Don't reduce. Super easy to find a reciprocal of a fraction. I did one up here. The reciprocal of 2/3 is 3/2. The reciprocal is just inverting the numerator and the denominator. The reciprocal of 4 I said is 1/4 because if I wanted to find the reciprocal of 4, to do a reciprocal, I need to find the fraction form of an integer. Because 4 is equal to 4 over 1, its reciprocal is 1/4. This is an important skill that's going to make us able to divide fractions, which is coming up in a bit. So super easy. The reciprocal of 4/3, 3/4 is 4/3. I don't really know how to write my answer so well. I should probably just write the number and not write the word reciprocal every time. But the reciprocal is 4/3. When we're dealing with fractions and negatives and finding reciprocals, it doesn't matter where you put the negative sign. Just as long as when I create the reciprocal that I have a negative sign somewhere, it will be correct. There's multiple ways to write the correct answer. So for 20, the reciprocal of that fraction can be written at least 3 different ways that I can think of off the top of my head. I can just take the fraction and flip it and write 11 over -6. That's a positive 11 divided by a -6. That's some negative number. I don't know what the decimal equivalence is, but it turns out that this fraction that has negative 11 in the numerator and 6 in the denominator, if I created a decimal equivalence for this, these are going to be equal to each other because they're both 11 divided by 6 made negative, which would be an acceptable answer as well. Similarly, if I created a fraction and just stuck a negative and said the opposite of 11/6, that would also be an acceptable answer. It turns out that when I'm dividing fractions, it's probably most useful to me to have that form of the reciprocal. It kind of maybe depending on what I am doing with the reciprocal after I find it, that's probably going to influence how I write my answer. But any one of those three is completely correct. 22 wants me to find the reciprocal of 8. Because 8's an integer, I need to write it as a fraction. And the reciprocal of 8, or the reciprocal of 8 over 1, is 1/8. For 24, I need to think of this as negative 4 over 1. And it's reciprocal because it has that negative, probably has 3 options. And it could just be completely just flipped, positive 1 in the numerator, negative 4 in the denominator. Or I could leave the negative in the numerator, positive in the denominator, or I can write the negative out front and then create the fraction 1/4. All of those are acceptable reciprocals, and as I'm thinking ahead of what's coming, I think this is probably going to be the most useful reciprocal when we get into the dividing part of this section. When I made common denominators, I did 2 kind of options, one with a mixed fraction, one without a mixed fraction. In this case, leaving it as a mixed fraction, I don't know that I can get the reciprocal that easy. So that strategy of leaving the coefficient, for lack of a better term, the whole number part, is probably not a good idea. So to find the reciprocal, first I'm going to change this to a mixed fraction, or an improper fraction, should I say. Right now it is a mixed fraction. So I'm going to multiply the 3 times the 7 and add 2. So multiply and add. 3 times 7 is 21. 21 plus 2 is 23. So 7 2/3 is equal to 23 over 3. And now I can find its reciprocal. The reciprocal of 23 over 3 is 3 over 23. And then last one, and then we'll do a part 2 to this video. So for 28, I need to make this into an improper fraction. I'm going to go 7 times 9 and plus 4. So times and plus. 7 times 9 is 63. 63 plus 4 is 67. So the mixed fraction 9 4/7 is equal to the improper fraction 67 over 7. And now I'm going to find its reciprocal, which is going to be 7 over 67. Alright, so let's pause and do a part 2 to this video, just so that it doesn't get any longer than 25 minutes. I kind of like to stop at 25 when I can.